Hello, welcome back to Chapter 8, Section 3, Adding, Subtracting Rational Expressions. For us to move to the next part where we need to find a common denominator, we have to find what's normally called a common multiple. And I know that gets confusing. Think of it this way. Common denominators, or the least common denominator, is the common multiple. It's just that it's special because we're putting it in a denominator. That's all. Least common multiples don't need to be any place at all. If we say least common denominator, those are LCMs that are in denominators. Maybe I made it worse. Who knows? Okay. These are the steps that the book gives you. Factor each polynomial completely. Write any repeated factors as powers. I'm going to ask you to avoid that. Dr. Berger wants this, that's fine, but for our purposes, sometimes it's easier to see them all written out. So it says, if you were going to factor x cubed plus 6x squared plus 9x, first you have a GCF of x, so you get that out of there, and then this becomes x squared plus 6x plus 9, which is x plus 3 times x plus 3. They want you to write it as with a power, like x plus 3 to the second power. I think that might actually be a little hard to see, so it's okay if you don't. I'll let you go on that one. Then this is where it gets confusing. It says list the different factors, and if the polynomials have common factors, use the highest power of each common factor. Yeah, I know. So let me try to break it down this way. Let's forget about polynomials for a moment. Let's just talk about understanding what happens. Usually when we have a complex problem, if we can model it with a smaller, easier problem, it helps us understand what to do when we get to the complex part. So I want to find the LCM of these two numbers. Let's find the LCM of 18 and 12. So here's what we're going to do. We're going to factor both of them. 18, we're going to factor them in the primes. Let me be clear about that. 18 is 2 times 9. And 9 is 3 times 3. Now again, I could write 2 times 3 to the second power, but let's just leave it expanded as it is for now. 12 is 2 times 6, and 6 is 2 times 3. Now, notice that these are not the same, obviously, but they have some factors that are in common. All right? So my least common multiple is going to have all of these factors, except I don't have to repeat the factors that they share. So notice that they both share a 2, and I'm only doing this for demonstration purposes. I'm going to put a circle around those. There's no reason to write a circle. I'm just trying to draw attention to the fact that they are shared. Okay? The 18 has a 2, so does a 12. So the LCM has to have one of those 2's. Same thing with the 3's. They both share a factor of 3. Now, 18 has a factor of 3 and 12 has another factor of 2. So I need to include both of those. Now, and here's how to look at it, okay? Is this a multiple of 18? Well, 18 is going to be 2 times 3 times this 3. So if I multiply the 2 times 3 times 3, I get 18. And then I multiply it again by 2. Yes, this is a multiple of 18. It's 18 times 2. The 18 is inside here. There's the 2, there's the 3, and there's another 3. Same thing with the 12. 12 is right here. 2 times 2 times 3, whatever the order is. And if I take that 12 and multiply it by 3, I get a multiple. So what is my multiple? It's going to be 6 times 6, which is 36. 36 is 18 times 2 and 12 times 3. Okay, let's try it again. Let's pick a different pair. Let's say 25 and what did I write down? 15. So 25 is going to be 5 times 5. And 15 is going to be 3 times 5. So my least common multiple has to have this 5, and I don't need to repeat it since it's in both of them. But I also have to include my other 5, because I need 5 times 5 to make a multiple of 25, and I also have to include the 3. So my least common multiple is going to be 5 times 5 times 3, which is 75. 25 times that 3 that was in the 15 equals 75, and 15 times the other 5 equals 75. And I got one more, and this one's something weird happens that I want to point out. I picked it just so that weird stuff would happen. So 8 is 2 times 2 times 2. 2 times 4, which is 2 times 2. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. My least common multiple, so both of them share a 2, both of them share another 2, both of them share another 2, and this extra 3 came along for the ride. So my least common multiple is going to be 2 times 2 times 2 times 3, which is 24. Sometimes the least common multiple happens to be one of the numbers. Why? Because 8 times 3 equals 24, and 24 by itself, 24 times 1, I should say, equals 24. Well, how do we do this if we've got variables in monomials or if we just have polynomials? So let's look at this. So I'm going to expand by factoring with these monomials. I'm going to expand by factoring what I have. So 2x cubed y to the 4th is going to be 2 times x times x times x. 1, 2, 3, x cubed. Times y times y times y times y. 3x to the 5th, y to the 3rd, it's going to be 3 times x times x times x times x times x times y times y times y. My least common multiple, it has to have a 2. There's no shared 2 here. It has to have a 3. But now the shared x's, I'm only going to write once. X times x times x, for each pair that's shared. Sorry. But of course I've got a couple of extra x's here. And the shared y's, I don't know if I can do it this way, all right? I'll do it like that. So I've got y times y for the shared ones, and then I got 1, 2, 3 more left over. So you're probably going to notice a shortcut with this. 2 times 3 is 6. I've got 1, 2, 3, 4, 5 x to the 5th power. And I got 1, 2, 3, 4, 5 y to the 5th power. So basically, if I look at this, oh, did I miscount my y's? I think that, oh, I did. I'm sorry. 1, 2, 3, 4, 5. Just double checking. I had 4. Just double checking. I should have y to the 4th power. Yeah. Y to the 3rd, y to the 4th. It's like throwing me off because that's what I... 1, 2, 3. Hang on a second. I'm just looking at this weird. I know this is bad video that I did, and you probably see it already. Of course. It's because of this. I'm so sorry. I had to do that. It's because it wasn't lined up right. So I got an extra y in there that I shouldn't have. Took me a while to see it. This is actually y to the 4th power. Okay, so this is why I caught that. That's because that x to the 5th, x to the 3rd, x to the 5th, I take the biggest exponent that I have here. And this y to the 4th, same thing. I take the y to the 4th. All these y's are included in that one. It's that extra one that I need. I can't believe I did that. Yeah, things happen. What happens if you got polynomials? All right, so I'm going to write it right here. X squared plus 3x subtract 4. I'm going to factor that. What two numbers multiply to give negative 4, add to give a 3? That's going to be x plus 4 times x subtract 1. And x squared subtract 3x plus 2 factors into what two numbers multiply to give 2, add to give 3, x subtract 2 x subtract 1. So the least common multiple is going to have the x plus 4, the x subtract 1, also the x subtract 2. That's because this extra x subtract 1 is already in both of them, like we did here and like we did here. And of course I would remultiply that to see what it looks like. But I'm not going to do that for right now. For the last one, x squared subtract 4, that factors into x plus 2 times x subtract 2. And x squared plus 5x plus 6 factors into x plus 2 times x plus 3. So the least common multiple, they both share an x plus 2. So I only write that once. Then whatever extra I have, x subtract 2, x plus 3, that is included in the least common multiple. I know it gets a little confusing with polynomials, but the method is the same as if we did it with constants. All right, I'll see you in the next video.